Hello to my advanced algebra students. Unfortunately, I've already recorded this video once and it didn't take, so we're going to have to do it a second time. So we are going to have another day in 13.3. Well, this is, I'm putting it in section 13.3. Really, this is a review of things you learned in geometry but are necessary to understand for what you're going to be looking at now. So just be aware of that. So this is 13. We're going to call it in 13.3, but it's really learning trig ratios. Okay, so the first thing to remember from geometry is that all right triangles with one other congruent angle are similar. So if you remember, similar triangles are triangles that have all three pairs of corresponding angles congruent. And what that means is the triangles are the same shape, even if they're not necessarily the same size. So that's one of the things that happens with similar. Well, in a right triangle, you already have a right angle, so you already have a pair of right angles. If you have one other pair that's congruent, then that means that the third pair also have to be congruent because they all have to add up for 180, so you know you have similar triangles. And if you have similar triangles, then you know their sides are proportional. So all triangles that share, all right triangles I should say, that share that one angle in common, one congruent angle common, they will be similar and their sides are going to be proportional. So in other words, they will have equal ratios. So whatever the ratio is for one, those will be the ratios for the others. All right, because of that, for any given angle theta in a right triangle, we can calculate what are called sine, cosine, and tangent ratios. So these are different ratios that are comparisons. You know, ratio, remember, is putting two things in comparing in a fraction form. We can do that, compare them in fraction form like this for these different sides of the right triangle. Of course, the question you probably should be asking yourself at this point is, well, what's a sine, what's a cosine, and what's a tangent ratio? Have no fear, I will tell you. So, first off, we abbreviate the trig ratios with three letters. So we read this as sine. This is not the English word sin. It is the math abbreviation for the sine ratio, S-I-N-E. We only use three letters for all of our trig ratios. So this is the easiest thing to do is just take the first three letters. And that's what we're going to do for all three of these, sine, cosine, and tangent. So the sine of, and whenever I talk about the ratio, it always has to be in reference to an angle, because the ratio is not unique unless I specify an angle. So in this case, it is the sine of theta. So for some theta in our right triangle. So we're assuming right triangles, and we're assuming a common angle of theta. Well, we know that ratio is going to be the opposite side over the hypotenuse. And then for the cosine of theta, we know that we are going to have the adjacent side over the hypotenuse. And so we've compared the opposite to the hypotenuse, so those two are compared together. The adjacent to the hypotenuse, the only thing we haven't compared yet are the opposite and adjacent together. That's what the tangent of theta does, and it compares them by putting the opposite over the adjacent. So let's look at what this actually looks like visually. So visually, if I've got a right triangle, and I've labeled sides A, B, and C, and I've labeled an angle theta there, there's my angle theta in my right triangle, we can look at these different trig ratios. So if I look at the sine of theta, notice for the sine, I want opposite over hypotenuse. So for the sine of theta, I look at the opposite side, which is the side A. It is the side, notice this is the hypotenuse. This is the side that is next to theta. It is the adjacent. So this is A over the hypotenuse C. So then if I look at the cosine of theta, now I want the adjacent side. Well, this is the hypotenuse, this is the opposite, so that leaves only B as the adjacent. It is the side that is next to the angle here. So it helps form the angle theta. It's one of the sides of the angle theta. The angle theta is formed by both one of the legs, that's the adjacent, and the hypotenuse. So that's going to be B over C. Finally, for the tangent of theta, I've got the opposite side, which was A, over the adjacent B, so I have A over B. Now, you may be thinking, okay, that's easy enough to figure those out, but I don't know that I'm going to remember what the sine, which sides the sine compares, and the cosine and the tangent. Have no fear, we have a great way to remember it. To remember it, all you have to do is think about a name that sounds like a math summer camp. I'm sure you all want to go there. It's called Camp SOHCAHTOA. And if you notice, the letters here help us remember exactly these trig ratios. So, SOH is from sine is opposite over hypotenuse. Sine opposite over hypotenuse. CAH, cosine is adjacent over hypotenuse. Cosine adjacent over hypotenuse. And TOA, tangent is opposite over adjacent. Just like we have there. If you remember Camp SOHCAHTOA, you should be able to remember how to compare your sides in trig ratios. All right, now we're ready for some examples. I think you're going to find this assignment rather simple. So let's look at a right triangle that you're given here. And notice we're given angles X and Y in our right triangle. And we've labeled our side lengths. Our side lengths are given to us. They're 1 and 2 for the legs and radical 5 for the hypotenuse. So let's find the sine, cosine, and tangent ratios for these angles. So first we're going to look at the sine of X. So I look at this angle X. So the sine is going to be the opposite side, 1, over the hypotenuse, radical 5. So the sine of X is just 1 over radical 5. And then we'll look at the sine of Y. So looking at Y, the opposite is 2. The hypotenuse is radical 5, so the sine of Y is 2 over radical 5. Now let's look at the cosine of X. Cosine of X, adjacent side is 2. Hypotenuse is still radical 5, so I have 2 over radical 5. And now we'll look at the cosine of Y. The adjacent side for Y is 1. It's the leg that helps make the angle Y. And the hypotenuse is still radical 5. Finally, for tangent ratios, when we have the tangent of X, so I look at X here, the opposite side is 1, the adjacent is 2, it is 1/2. And then for the tangent of Y, the opposite side is 2, compared to Y here, and the adjacent is 1. We have 2 over 1, but we always want to reduce these when we can, so we'll call that 2. All right, last thing you're going to have to do involves using your calculator. So we want to use our calculator to find the following. The first thing is the sine of 26 degrees. So let's talk about how we do this with our calculator. So I'm going to flip the light here so it's going to be a little bit easier to see the calculator as I put the calculator screen here. So the way that we're going to do this, the first thing we have to do with our calculator is you have to check and make sure it is in degree mode. Notice mine is in radian mode right here. That's because I do a lot of work in radians for all my other math classes. We talked about radians. That's another way to measure angles. If we are talking about radian measure, we want it in radian mode. So one thing you can do is you can leave it in radian mode, but if you leave it in radian mode, you have to actually put your degree symbol in your calculator. So I'll show you how to do that first. So if I go to get the sine, I have to go to my trig button. It's right here on my calculator. So if I hit my trig button once, this menu pops up. Notice sine is the first choice in the menu, so I'll just hit enter and I have the sine. I'll put in 26, but it'll think it's radians unless I tell it's degrees because I'm in radians. So I will go to this button right here, right down there, and I'll hit that, and then I'll see that the fourth choice of that button is my degree symbol. So I'll just go over there, select the degree symbol, and I have 26 degrees. Now if you have a CAS calculator and you just hit enter, it'll try to give you an exact answer. And so watch what it does. It does this. You don't want that. Go ahead, when you hit this enter, hit control enter, and you'll get your decimal answer. That's what you want. If you don't have a CAS calculator, you don't have to worry about hitting control before enter. All it can give you is a decimal answer, so it will give you the 0.438. So we enter our 0.438. Well, a lot of you are just going to want to turn your calculator to degree mode. So let's talk about how to do that. So if your calculator is not already in degree mode, what you want to do is you go hit your home button, go over to settings, hit enter. Under settings, pick document settings. It's choice 2, hit enter. You'll notice your third choice there is angle, right there. So mine says radian. I want to go there and I want to change it to degrees. So I will select degrees. It's still not into degrees yet until I go down to the very bottom and click on make default. They ask me if I really want to do that. I say yes. And now I've actually changed it to degree mode. Now when I go back to my screen to evaluate, you should see it'll say DEG up here. So let's do the next one. The next one is cosine of 22 degrees. So once again, pulling out my calculator, I'll hit the trig menu, but cosine is my second choice, so I have to hit it twice to get cosine. Hit enter, put in 22. I don't have to use the degree symbol now because I am in degree mode. Just hit control enter, and I get 0.927. So I have my 0.927. Final one, tangent of 87 degrees. So for this one, I'll hit my trig menu again, but I have to hit it 3 times to get to tangent. Put in the 87, and I get 19.081. It's that simple, that's straightforward. Okay, homework is going to be your trig ratios worksheet, and I'll attach this to your assignment so that you can go ahead and do that. It's 1 through 22, all of those. I think they'll go very quickly. And so I hope things go well. I hope you have a great Easter weekend ahead, and really enjoy the opportunity to remember the wonderful gift that we have from our Lord and Savior in salvation. All right, we'll talk to you guys later. Bye.